We're very excited to have you this morning. Our first speaker this morning is Eric Ferrebee. Tell you a little bit about Eric. Eric is the Director of Technical Services for the American Concrete Paving Association, and he's held that role since 2014. Eric is responsible for providing technical resources and consulting services to all ACPA members and agencies and owners that they serve. He holds a BS and an MS degrees in civil engineering from the University of Illinois, and he's a licensed professional engineer in Illinois. So please welcome Eric.
Good morning. All righty. Nice to see so many of you are out here and up and at 'em, ready to go early, especially when we're talking about concrete pavement design. I know it's not everybody's favorite topic, but we'll make it a little fun here. We'll show a few demonstrations, and you guys will get a chance to see a program in action. So my talk today is really about pavementdesigner.org, and it's kind of this new tool to design cement and concrete-based solutions for parking facilities, municipal streets and roads, as well as industrial facilities. So there's a lot you can do with it. But in talking about Pavement Designer, I think it's always important to put things in context. So we're going to talk a little bit more broadly too about concrete pavement design in general. Does this thing work? Nope. All right. I can just use the arrows. There we go. All righty. So our focus today is going to be on pavementdesigner.org. And so to give you an idea of what pavementdesigner.org is, it's a new tool for designing concrete pavements. So you can design parking lots, you can design streets and local roads, you can design intermodal facilities, so you can do a lot with it. And even within streets and local roads, you can design for overlays, you can design for full-depth concrete pavements, and you can also design for composite sections as well. Now this tool was developed by the concrete pavement industry. It was a partnership between the American Concrete Pavement Association, the National Ready Mix Concrete Association, as well as the Portland Cement Association. We also had a little help from the RCC Pavement Council as well, so there's a lot of people involved in developing this and making sure that it was the best tool for designing concrete pavements that it could be. So I've mentioned that this thing is multifaceted. We really kind of, as a concrete industry, recognize that there are a few tools out there for designing highways for concrete pavements, say AASHTO Pavement ME and AASHTO 93. But when you started looking at other types of facilities, like your parking facilities or your intermodal facilities, there wasn't really a good tool for doing that. Additionally, when we looked at streets and local roads, that may not be able to be designed with Pavement ME, which we kind of consider a really good tool. So we also felt there was a need to develop a tool for that type of market as well. Additionally, most of those tools are really focused on jointed plain concrete pavement, but we also felt that there was a need for a design tool that did overlays for these types of facilities as well as roller compacted concrete, and also looking at cement treated soils, full depth reclamation, and all of those other things that we can do with cement to make sure that our pavements can last as long as we want them to last. Excuse me. So one thing that I always like to note before we get into Pavement Designer and actually look at the tool and start looking at different design methodologies is that while Pavement Designer is a new tool, the methodologies that it's based on have been around for quite a while. This isn't a new design procedure that we just came up with out of thin air. It's based off of some very well-recognized and well-used tools for designing concrete pavements. So this map is something that I'll refer back to a few times, and you can actually find this on the Pavement Designer website. But it gives you a little idea of what design methodology is being used to power the design that you're doing. And so I'll refer to this a few times. So a few other reasons why we wanted to develop this tool, besides that we saw the need in different markets to have a new tool for concrete pavement design. We also recognized that consulting engineers as well as cities and counties really needed a good tool for concrete pavement design as well. A lot of times the DOT, we know that the DOTs are more shifting towards the more robust tool of AASHTO Pavement ME, which is great, but that kind of leaves some of the smaller agencies kind of behind. So municipalities may not have access to that tool because it's fairly expensive, so we really wanted to build a tool for them as well. Additionally, we recognize that a lot of students coming out of the universities at the university level don't have a good background in concrete pavements or concrete pavement design. Now, Pennsylvania is a little different. You guys have Pitt. You have some of the best concrete pavement researchers around, which is great, so I'm sure that they get a good background in concrete pavement design. But also those professors like Julie Vandenbosch and Lev Kazanovich, they also need tools to actually teach concrete pavement design. So pavementdesigner.org is one of those tools that they can use in the classroom as well to educate the next generation of concrete pavement enthusiasts. And finally, one of the last big reasons why we developed this tool was because we recognized that there needs to be a free resource for designing and developing concrete pavement design. And so pavementdesigner.org is a free tool. You can go there right now and start designing right away. You don't need a whole background, or you don't need to pay for anything. You can just go and start designing right away, which is another great aspect of the tool. Okay, so we're going to start off, we're going to look at the three main things that you can do with Pavement Designer. You're going to look at parking lots, we're going to look at streets and local roads, and we're going to look at intermodal facilities as well. So we're going to look at all three of these areas in turn. So we're going to start off with parking lots. So when we look at parking lot design, and I mentioned that this is one of the gaps that we were trying to fill, the main ways that you could design for parking lots were originally AASHTO 93, which is supposed to be a highway design. You could design with ACI design documents, which we'll step through in a minute, or you could design with Street Pave. Now, Street Pave was actually the predecessor for Pavement Designer. It's actually what's powering a lot of the design within Pavement Designer, so that's already featured within the design. So if we look at ACI 330, which is one of the main ways that parking lots have been designed for concrete pavements, you can see that most of the design is really based off of these design tables. And so it doesn't allow you a whole lot of flexibility with what you can do. You're kind of restricted to what's featured within these tables. And so it's really not one of the best ways that you can design. It's kind of limited in what it can do. Now, having said that, it's also interesting to note that those ACI tables are actually based on street pave runs, and now the new guide that's coming out here in 2019 is actually based on Pavement Designer runs. So it's actually following the same design methodology that we have within Pavement Designer. So it's really kind of the same tool. And that's good. We're trying to all stay on the same page with what's the best design for parking lot design. But when we have the guide, we're really just looking at tables versus having a tool where we can have some flexibility in what we try to design for. Alrighty, so the parking lot design within Pavement Designer, where we have that flexibility, where we can adjust things and look at how things are impacting our design. This design methodology is based on an older tool called Street Pave, which is developed into a lot of the guts that power pavementdesigner.org. And so this was the evolution from Street Pave to Pavement Designer. Really, the main goal is making it free and making it even more easily accessible than it has been in the past. Alrighty, so now I'm going to actually show you guys a little bit of pavementdesigner.org. You guys are going to see an example of a parking lot design within the tool. So let's see if I can get this to work. There we go. So we're actually going to, a little too high. Let's try that. Okay, so we're going to actually go through a design with pavementdesigner.org, looking at doing a bus terminal that serves about 50 buses a day, and we're going to assume a 20-year design life on an existing subgrade of clay. Alrighty. So when you arrive at pavementdesigner.org, maybe. Let's see here. Nope. Wrong one. Okay, there we go. All right, so when we arrive at pavementdesigner.org, you can see that we can start designing without doing anything. We don't have to create an account. We can actually just start designing. So if I go in here and I click Start Design, you can see that the first step within any of our designs, we have to choose what type of facility we're designing for. We're designing for parking lots, streets and local roads, or an intermodal facility. And if you're not really sure where you belong, each of these has a little flip screen that gives you a little more idea of what's featured within that design module. So this gives me a little bit idea. If I'm doing a bus terminal or if I'm doing a truck parking facility, I'd probably want to be in the parking lot design methodology. Okay, so when we get into the parking lot design, let's see if I can make this a little bigger for you guys. There we go. So when we get into the parking lot design, you'll see that each of our designs is broken out into a three-step process. We have our project level details, our pavement structure details, and our summary details. And so this is how we approach each of the design methodologies, trying to keep it as simple as possible. That's one of our biggest goals with Pavement Designer, to keep things as simple as we can. So within our project level details, the first thing that we have to do is define our traffic. So we do this by selecting a traffic spectrum. Now for this one, I made it fairly simple. We're designing for a bus terminal, and so that corresponds to ACI spectrum C. And we'll touch a little bit more on this as we get into the other design methodologies. So the next thing we have to do is we have to determine a design length. And so I specified this as 20 years for this parking lot facility, which is fairly common. So we could say 20, we could go up to 30 or 40, but for this example, we're just going to say it's a 20-year design life. The next thing I have to do is input my trucks per day. So for this, I specified we have about 50 buses per day, and that's going to serve as our truck traffic for this facility. We're going to say 50. Okay. So next thing we have is a reliability and percent slabs cracked at the end of the design life. So now this isn't something that I specified within the problem statement, and I'm really not sure what it should be. So I'm going to go ahead and turn on my help screens. And so you see this little help button that we have at the top. We can actually turn help screens on and off. And so if I turn them on, you'll notice that each of our inputs has a little hover over slide. So if I hover over the input, then I can see a little description of my input. I can also click on more information, and I get a little more detail on what we're requiring within that input. So if I'm looking at a bus terminal, a bus parking facility, I'll probably be more in the local roads area, so I'll probably want to be between 50 and 80% reliability. So I'm going to say about 75%. It's a fairly important bus parking lot area. So the next thing we have is percent slabs cracked at the end of our design life. So if I go ahead and click in here at the help screen as well, you can see I'll probably want to be somewhere in the 15 to 25% range. So that's about what I'm going to expect for percent slabs cracked. So I'm going to say 20% at the end of my design life. And so once I do that, I can move on to my pavement structure. And so when I get to my pavement structure, you can see that we need some additional materials or additional information about the materials that we're building with. We need some information on our subgrade materials, we need some information on our concrete materials, and then if we're going to have a structural layer or not. So the first thing we need is our information on our subgrade. Now one of the things that I specified in here was that we had a clay subgrade, fairly weak soil. So if I go in here, you notice that we actually have a table, and you can see that we have a little description of what these types of soils are. So instead of actually putting in a number here, I can just select from this table, and it gives me a value within that subgrade CBR. So that's step one. The next step we have to do, we have to define our concrete materials. So here we're really just defining a strength for our concrete, and this can be whatever we like it to be. I'm going to say it's going to be about 3,500 PSI concrete. Oh, but wait, I have it specified here as flexural strength. That would be quite high for our flexural strength. So I can actually choose here if I'm doing compressive strength, modulus of elasticity, or split tensile strength. If I'm looking at 3,500 PSI, I'm probably going to be a compressive strength. So that's what I'm going to specify. And notice we have those little flags within Pavement Designer throughout the design to make sure that we're checking you and making sure we're not letting users put in something that's completely irrational. Okay, so now you'll notice once I get those materials in, you'll see that this K value for our substructure calculates. Here we've got 100 PSI per inch, but I can also add a subbase layer in here, so if I want to add an aggregate layer between my parking lot surface and my subgrade, I can do so. For this example, I'm just going to say that I'm putting it straight on the subgrade. So I have a very weak soil, and I'm putting it straight on that subgrade. So once I'm done with that, I can move on to my design summary. You'll notice that we have a calculated minimum thickness, a recommended design thickness, as well as a maximum joint spacing. So we're trying to guide the user through that design process, as well as give them some background information on what they're designing for. You'll also notice that we have some sensitivity plots, and these are kind of giving you an idea of how your design is impacted by, say, one input. So if I change that K value that's defining my substructure, you can see how it would impact my design. So I had a K value of about 100. You can see if I put, say, a subbase in there and got that K value up to 150 or 200 PSI per inch, you can see that I could save some of my thickness in my concrete. Similarly with concrete strength, as I change my flexural strength of my concrete, you can see it would impact my design thickness of my surface. So we have these for K value, concrete strength, our design life, reliability, and percent slabs cracked. You'll notice with these two, as we get out to the edges, say if I want to be 100% reliable, I obviously have to build in a lot of extra concrete to make sure that my pavement doesn't fail. So a few handy calculators, a few things that can help you think through your design, because once we get to this page, it's not a completely done design. We have to analyze it as engineers and make sure that it's okay. You also notice that we have cracking and erosion reports. This is giving you an idea of how the pavement's actually going to fail. Is it failing by cracking or is it failing by erosion and faulting? And you can see which of the axles are actually doing the most damage within this design as well. So the last thing we have is a joint spacing. This is giving you an idea of how this joint spacing is actually calculated, so it gives you an idea with that there. So that's a little bit on the parking lot design. Yeah. Let's see here. Let's go ahead and click that up. All righty. Okay, so back to our map. So we've gone through parking lots over here on the far left. Now we still have streets and local roads as well as intermodal facilities, so we're going to go through those pretty quickly. So I'm going to spend a fair amount of time on municipal streets and local roads, just to give you a little guys a little background of the ways that we can design for concrete streets. So in the So within pavement design or within the streets and local roads section, we can design for overlays, we can design for full depth concrete, or we can design for composite pavements. We're going to focus today on just jointed plain concrete pavement, so your full depth concrete sections. So the way that you can design for full depth concrete pavements, the existing methodologies that are out there, we can design with AASHTO 93, we can design with Pavement ME, or ACI has another guide that we can use for designing these types of facilities as well. So if we look at each of these relatively quickly, we're going to start with AASHTO 93. So AASHTO 93 is one of the most popular design methodologies for all of concrete pavements. It's really kind of ingrained in pavement engineers as a design methodology for pavement design. Now, there are some issues with that. The first issue is that AASHTO 93, as well as its predecessors, are all based on the AASHTO road test. And the AASHTO road test was performed in the 1950s in Illinois. So basically, we're designing our concrete pavements based off of a 2-year road test that we did in Illinois. And so there are limitations to doing that. When we do a road test in Illinois, it's going to have Illinois local materials, Illinois local subgrade, as well as Illinois, as well as an Illinois environment. Now, that can be a problem when you're projecting out to different areas of the country. So we have a limited inference space that we're basing all of these designs off of. And again, it's based on 1950s construction practices as well as 1950s materials. So a few problems with there. So for 2 years, they basically loaded these 6 test loops, and out of that, they got the AASHTO 93 design equation. It was updated a few times in 72 and 1972 and 86 and 93, and 93 is kind of where they ended it. So now, one of the biggest problems with AASHTO 93 is that on the concrete side of things, we didn't actually do a good job of getting a full performance history of our pavements. At the end of the 2-year road test, they still had 70% of their concrete sections in good condition. And so that's, on one side of things, good. Concrete lasts. It performs really well. On the other side of things, when we're doing a road test, we expect to fail our sections to understand how they're performing. And we didn't do that with the concrete side of things. So the General Accounting Office of the United States actually took note of this, and they said, Highway Pavement Design Guide is outdated. And so that's really why Pavement ME exists. So Pavement ME is kind of the gold standard right now for designing concrete pavements. Now, Pavement ME is really developed for the highway market. It's really developed for these higher level facilities that are managed by state DOTs as well as federal agencies. So that's really what it's developed for. It's not really for streets and local roads and parking lots, so it doesn't really trickle down to those types of facilities. Now, it's a great tool, and I really I enjoy using it, but because it's developed for the highway side of things, it's fairly complex. You can actually control a lot of different aspects of your pavement right within Pavement ME, and because of that, you can actually see how all these things impact your long-term pavement design. So it's a great tool. but it doesn't really trickle down outside of the DOT type market. Additionally, and one of the big reasons besides complexity for it not trickling down is it's expensive. One license for a year for Pavement ME is $5,500, so it's fairly expensive. And so it's not really going to go down to the streets and local roads or municipal type markets, and so we expect that's the case. So a lot of times designers in those types of areas revert back to AASHTO 93. And that's really why we saw a need to develop Pavement Designer to kind of fill that gap that's being left by DOT, the DOT type markets moving towards Pavement ME. So just looking at some of the differences between Pavement ME and AASHTO 93, when we look at AASHTO 93, there was one test section. It was right about here in Illinois, so right in the heart of Illinois. When we moved to Pavement ME, they put test sections all over the country. And we evaluated pavements with different materials from all over the country, with different environments all over the country, and we evaluated them for a long time. Instead of just 2 years of data, we got 20 years of data, 20 years plus. So a lot of things that we're evaluating the performance of our concrete sections. So that's great. We're getting a full performance history of our concrete pavements. If we take a look at the differences between AASHTO 93, at that road test, we had about 1.1 million load repetitions. Those test sections across the country have over 50+ million load repetitions on some of them. So we have a much fuller history of our traffic and how it's impacting our pavements. Additionally, we had one set of materials from Illinois for that road test. Now we have materials that we're evaluating from all across the country. We also had limited structural sections, we had limited climate data, and now we've really blown that up as we move to Pavement ME. So that's really why Pavement ME is such a robust tool and why it's such a good tool, because we're evaluating all of those different aspects that impact pavement design. But that kind of gets back to the complexity. When you can control all of these different aspects of a pavement design, you have a lot of different things that you can evaluate. And so each output file from Pavement ME, this is an output report, is about 16 pages long. So because you can control so many different aspects of your pavement design, you can evaluate a bunch of different aspects of how it's impacting the pavement, and you can see that there's a lot of data that's featured within that design. And so it's fairly complex. And so within Pavement ME, you've got 3 failure criteria. You've got roughness, you've got faulting, and you've got cracking. And that's really how you're designing your pavements. Now that's compared to AASHTO 93, where we really only have a serviceability index. That's how they're characterizing failure. All right, so that's a little background behind AASHTO 93 and Pavement ME. One last thing that I'll remind about Pavement ME is that, again, it's fairly complex and it's also fairly costly. And that's really the gap that we're trying to fill with Pavement Designer. So the last way that we can design streets and local roads outside of Pavement Designer is with ACI. ACI, again, has a guide for streets and local roads. It's very similar to the one for parking lots in that you're designing based off of tables. And so that, again, gives you limited value as to what you can control and do with it. Additionally, this guide is actually based on Pavement Designer runs, and I believe it's being released later this year. The one before it was actually based on the predecessor for Pavement Designer as well. And so that brings us back to Pavement Designer. So Pavement Designer for streets and local roads, again, this methodology isn't new. It's something that's been around for quite a while. It's been fairly well accepted, and it's really designed for streets and local roads. So this methodology dates back to the 1960s. So basically, right after the AASHTO road test, that 2-year design road test that we had, we recognized that those were really designed for highway-type facilities. So how do we design for concrete pavements at the street and local road level? So they developed this design methodology. Now it's evolved over time to improve and get better and consider more things, but it's really still kind of tailored for that streets and local roads type market. Now one of the big benefits of moving away from AASHTO 93 towards Pavement Designer or Pavement ME is that each of these methodologies are mechanistic empirical. We're not just evaluating it based on a road test. We actually have mechanics of materials built into the design program. And so that's one way that Pavement Designer and Pavement ME are fairly similar. So failure modes within Pavement Designer are cracking and erosion, similar to faulting. So we're trying to improve how we're considering failure within the pavement design very similar to Pavement ME. Again, moving away from the AASHTO 93 procedure of just considering a serviceability index. All right. So that's your little background on Pavement Designer. So now we're actually going to see it in action for streets and local roads. So we're going to design for a municipal street. You can see our design is for Overland Parkway, where we have approximately about 100 trucks per day, and we're designing on a subgrade that's a poorly graded silt. All right, so let's see what we can do. Now, let's escape. There we go. So if we get back to Pavement Designer, and we start a new design, I'm not going to save that project, we're going to start a new one. So you can see we're back to our project type. So we've gone through parking, now we're going through streets and local roads. Again, you can see our little flip screen giving us a little detail on what we're designing for. So I'm going to design for a street and local road, I'm designing for a full depth concrete pavement. But here you can see that we can do an overlay, we can do concrete, full depth concrete pavement. We can also do a new composite pavement. All right, so we're going to do a full depth concrete pavement. I'm going to go ahead and here and select concrete. Let's see if I can blow this up even bigger. No, not quite. Okay, so you'll notice that we're still in our 1, 2, 3 type pavement design. We have our project level details, our pavement structure details, and our summary details. So we'll start off with project level details. So first off, we have to define our traffic. And so we have about 100 trucks per day, and so I have to select a spectrum for that. So I probably won't be in the major arterial or minor arterial area. I'm probably going to be in the residential or collector area, so I'm going to choose a collector for right now. Now, I didn't specify a design life, but typically when we're talking about concrete pavements, we're going to want a long life, so we're going to say somewhere around 30 years. That's where we're going to start. So next off, I have my trucks per day. So this one was actually specified at 100 trucks per day. And here's where I can actually turn on my help screens. I'm going to turn on my help screen and see that little hover over. If I click on more information, I can see that 100 trucks per day directly lines up with my collector traffic category. So I was right in selecting that collector traffic category up there in our first step in our traffic materials. Okay, so the next thing we have to define is a traffic growth rate. So if I'm in an area that's growing significantly, I may put in 3 or 4% or even more. If I'm in an area that's fairly stable, I may say 1 or 2%, so I'm going to say 2% traffic growth rate. So the next two inputs that I have are directional distribution and design lane distribution. So for directional distribution, if that 100 trucks per day is split between a north and southbound direction, I would say 50%. If all of those 100 trucks per day are in the northbound direction, I would say 100%. So I'm going to say 100% are going in my design northbound direction. So the next thing I can do is a design lane distribution. So if I have a facility that has 2 lanes in my northbound direction, I may say that 90% of my trucks are in my design lane, 10% are in the passing lane. For this facility, I'm just going to say 100% of my trucks are in my design lane. So you'll notice once I get those details in there, we calculate the average trucks per day in the design lane over the design life, as well as the total trucks that we're designing for. So that 100 trucks per day with that 2% growth rate over 30 years ends up being about 135 trucks when we average it out over the entire design life. So the next thing we need is a reliability. And again, if I'm not sure on this, if I have limited information, I can click on my help screen. For a collector facility, I'm probably going to be between 80 and 99%. So I'm going to say about 85% reliability. Next input is percent slabs cracked. And again, for new designers, we tried to make this as simple as possible, trying to boil it down to just the important inputs. But if we're not sure, we still always have those help screens. So for a collector road, probably around 15% slabs cracked. We also refer back to the terminal serviceabilities, give you an idea of what that might be, which is an AASHTO 93 kind of design idea. So we're going to say 15% slabs cracked. So then we can move on to our pavement structure. So here we can select whether we're doing our conventional jointed plane. You can also do roller compacted concrete or continuously reinforced concrete. So we're going to stick with jointed plane. And you can see here we have our similar screen where we're designing our subgrade first, then our concrete materials, and then our structural layers in between our surface concrete and our subgrade. So the first thing we have to do is define our subgrade. The information that we were given is that we have about an A5, a silty material. So if we go in here and we turn our help screens back on, if we go into our resilient modulus value, I'm not sure what that value should be for our A5. If I click on more information, you can see that I get an idea of what that range should be. So for a silt, an A5, poorly graded silt, we have a range of about 4 to 8 for a CBR, or 5,000 to 8,000 for a resilient modulus. So trying to guide the user through what those inputs might be. So I'm going to say 6,000 for my resilient modulus value. Okay, so the next thing I need to do is I need to find the strength of my concrete. So we can do this through, again, flexural strength or compressive strength. We also have modulus of elasticity or split tensile strength. Whichever one of these we select, again, we're going to refer back to our flexural strength. So if I input a compressive strength of 4,000 psi, it's going to calculate a flexural strength for me. So we also need a modulus of elasticity. We default to 4 million psi. But you could tie that back to the actual strength of the concrete, and we have a little table for that as well. So if we have a flexural strength of 600 psi, we would expect the elastic modulus to be about 4 million. Alrighty. So the next thing we can do, we can select whether or not we have macro fibers in our concrete. This is something that we see increasingly, especially in the overlay market. And we can also define whether or not we have edge support. So if we have, say, a widened lane or a tied concrete shoulder, we would consider it to have edge support. Also, if we had a tied curb and gutter section, that would count as edge support as well. Okay, so the last thing we need to do is define our structural layers, everything between our concrete surface and our subgrade. So here we can go from anywhere from 0 subbase layers all the way up to 3. So I'm going to say that I have one subbase layer. I'm going to choose a granular base. And I'm going to say I have about 4 inches of granular base in there. So when I do that, you can see that my calculated K value of the substructure is calculated as 305 psi per inch. If I'm a designer that knows that value and knows what we should have there, I can actually override that number and put in a user-defined K value. But for now, I'm going to stick with that 305 psi per inch. So then I can move on to my design summary. So you can see here it calculates my design summary. Since we have very low-level traffic, you can see that we have a fairly thin section at about 6 inches. You'll notice that we have a little more information here where if we're under 6 inches, we may not consider using a doweled section. But you can see we report both doweled and undoweled scenarios. We also have our maximum joint spacing, which is calculated here, is about 10 feet. So we still have our familiar sensitivity plots, our K value, our concrete strength, and you can see how these actually impact our design. So one here where I had a pretty high K value of about 300 psi, you can see that thins up my concrete section fairly well. However, when we're doing this, we always want to consider what happens when I do that, when I make my structural layer so stiff. It can also lead to other problems, so I may want to stay over here in a lower K value range, so it's something that we may want to consider as well. So it's nice to have these sensitivity plots to kind of analyze the design as we go. So we also have our cracking and erosion table. Again, this is looking at how our pavement is failing. Is it failing in fatigue or failing in erosion? We can look at it for undoweled and doweled scenarios because that may change which way we're actually failing, if it's cracking or erosion. So we also have recommendations on load transfer. This is giving you an idea of whether or not you need dowel bars. And then finally, we still have how that joint spacing was actually calculated. Now, one thing that I always like to show when I get here is that we can actually generate a report directly online. And so I can actually put in some more information, designer's name, the design name, as well as the route, owner, agency, and a project description. And then I can actually download and create that design report. So that report, you can see, we can generate it right online, and we can actually go ahead and print that out. So it's fairly versatile. So now if you did want to save your project, you would actually have to create an account. All we require for that is a username and a username in the form of an email and a password. And that's really just so you can access your designs anywhere. So you can, anywhere you have internet access, you can actually go online and actually get your, look at your designs or share them with people if you're looking to evaluate a design. All right, so I have one more one more quick street and local road example that I'm not going to go through in Pavement Designer, but I'm going to give you an example of kind of the benefits of using Pavement Designer or Pavement ME relative to AASHTO 93. So this is a design that I received a while back where they had done the design based off of AASHTO 93, again, that older design methodology. You can see that it's a fairly well-trafficked facility. You have about 20 million easels, or 7,000, or about 8,000 trucks a day. So they designed it for 90% reliability, 5% slabs cracked at the end of the design life. They had a 6-lane facility. So they also had some information about their subgrade support. They had an R value of 20. They had a concrete strength of 630 psi flexural, and they specified their their elastic modulus of their concrete as 3.5 million psi. They also knew that they were going to have a 1-inch asphalt subbase and 6 inches of cement-treated subgrade. And they were expecting a K value of 160 psi per inch. So the design they got with AASHTO 93 was 11 inches. So a fairly thick section. So I did this design with Pavement Designer and got about 8.5 inches, which is a huge disparity. So I also went through and looked at Pavement ME. And so Pavement ME came out at about 9 inches. And so this really illustrates the problems with AASHTO 93. It over-designs concrete pavements. And that's really why we push to go towards mechanistic empirical approaches. Now, Pavement ME is really the best way that we can design, especially this heavily trafficked interstate facility. So you can see the benefits of moving towards a more mechanistic empirical approach. We're not going to build in so much conservativeness into our design, and we're going to get a more realistic and competitive concrete pavement design. So really the thing that I'm trying to highlight here is that Pavement ME really is the best way to go, but Pavement Designer gets you really close to that, what we would kind of consider the more correct design for our concrete pavement. So these are just the reports from both of Pavement Designer and Pavement ME showing you that those thicknesses are what we calculated for that same truck facility and why AASHTO 93 may not be the best methodology for looking at these types of facilities. All right, I'm going to skip that. So real quick, I'm running out of time, but I do want to mention a few things about the intermodal design. When we do the intermodal design, or intermodal industrial design, what we're really looking at is looking at these forklift type loaders or say a truck or a container handler, really anything that doesn't have your conventional over-the-road type axles. That's what this design methodology is really for. And so you can do a lot with it. You can actually go in and you can actually place the tires for the vehicle. So I'm just going to real quickly show that. So if I go to New Design, and I go to my intermodal facility, you can see that it's a little different from what I've shown previously. So you can actually select an existing vehicle from our library. So if I select a vehicle, I can actually design with that. Or if I create a user account, I can add custom vehicles where I can control where that vehicle, where the tire loads are for that vehicle, and I can design that way. So a few different things that you can do with that. And it's really a great way for designing for those loads that may not be your conventional over-the-load trucks, which is what we would design for the highway side. So with that, I want to make sure that we keep us relatively on time. So I'll finish up there. If you have any questions, I'd be welcome to try and answer them, or I'll be around for the rest of the day, and you can come catch me at a break. So thank you.